Okay, dear students, haloalkanes and haloarenes lo important models చూస్తే the chiral compounds among the following is first one chiral means asymmetric means carbon has four different groups. If carbon has four different groups, that is called asymmetric carbon or chiral carbon. So according to this, if you see this carbon contains chlorine, hydrogen, chlorine, CH3. Two chlorines are there, so it is not asymmetric carbon. So if you observe second one, chlorine, hydrogen, two methyl groups are there. So one is below the plane, another one is on the plane, but both are same groups. If both are same groups, that is not chiral, so it is also not chiral. So next, if you observe third one, bromine, CH3. This carbon has bromine, CH3, two groups. So 1, 2, 3, 4, 5. 5 carbons, 1, 2, 3, 4, 5. Both are similar carbons, similar alignment. So it is also not a chiral carbon. So if you observe this carbon, it has one is iodine, another one methyl group, but it is not symmetrical. From right side onwards, 1 to second carbon contains methyl group. Left side onwards, second carbon does not contains methyl group. So it is asymmetric. So fourth one is asymmetric. Next, fifth one, hydrogen, methyl, ethyl. So both methyl groups are present. So it is not asymmetric. So it contains CH3, Cl, H, C2H5, four different groups. So it is asymmetric. So answer is 4 and 6. 4 and 6 are asymmetric. That means chiral. Chiral means the carbon which contains four different groups. So next, identify Z in the following reaction. 2 C3H7Br in the presence of sodium ether. 2 moles of C3H7 alkyl halides. When alkyl halides reacts with sodium and dry ether, it is a Wurtz reaction. It forms C3H7. One alkyl group combines with another alkyl, C6H14. C3H14. So N-hexane is formed. N-hexane. So next one, very important, it is X. When it reacts with MO2O3, molybdenum oxide at high temperature and 10 to 20 atmospheric pressure, either MO2O3 or V2O5, 6 carbons combines with one another, cyclic ring is formed and aromatization takes place. So removal of hydrogens at higher temperature, aromatic compound is formed, benzene. C7H16 is there, then methyl benzene is formed. 6 carbons are forms benzene ring, remaining as a side chain. So next, it is Y. It is reacts with anhydrous Cl3. Reacts with anhydrous Cl3 and methyl chloride. It is alkylation. Friedel-Crafts alkylation. Benzene reacts with methyl chloride in the presence of anhydrous Cl3. It is Friedel-Crafts alkylation. So then toluene is formed. So methyl benzene is formed. So answer is methyl benzene, toluene. So option C is correct. So next, the major product is CH triple bond C, CH2, CH double bond CH2, bromine 1 mole. Already I explained, 1 mole of bromine. If bromine is added in the presence of CCl4, it is the test for unsaturation. Double bond and triple bond reacts with bromine. But here only 1 mole. 1 mole means when compared to triple bond, double bond is more reactive. So that's why double bond is reduced to single bond and 2 bromines are attached to 2 carbons. So then CH, triple bond CH, triple bond C, single bond CH2, single bond CH, single bond CH2, 2 bromines are attached to the double bonded carbon atoms. If 2 moles of bromine is there, 1 mole bromine is attached to the double bonded carbon, another mole is attached to the triple bonded carbon, and triple bond is converted to double bond, 2 bromines are attached here. So very, very important, double bond is more reactive than triple bond. The next question, identify the product. Here chlorobenzene is given. So chlorobenzene, it reacts with NaOH at 623 kelvins and 300 atmospheric pressure. It forms Cl is replaced by ONA. Then it reacts with HCl, acid. So it forms NaCl and phenol. So OH plus NaCl. That means main product is phenol. So option D is correct. So first Cl minus is replaced by ONA. Next it reacts with HCl. It forms O minus Na plus. So H plus is added at O minus, Na plus, Cl minus, NaCl. So phenol is the main product. So next question. Chloroform in the presence of light. In the presence of light, slowly oxidized by air to form chloroform when reacts with oxygen. When chloroform bottle is open, it reacts with, chloroform is liquid, it reacts with air and it forms phosgene, COCl2. It is called phosgene. Phosgene, it is the poisonous. COCl2 is carbonyl chloride. It is the phosgene, it is the highly poisonous in nature. So COCl2. So option is A. Very important, very important. Next, phenyl magnesium bromide, C6H5MgBr reacts with D2O. So phenyl magnesium bromide, so C6H5MgBr, it can be dissociate into C6H5 minus MgBr plus. It reacts with D2O. D2O means D plus OD minus. D plus OD minus. So OD minus reacts with MgBr. MgBr OD is formed. D plus reacts with phenyl negative ion. It forms here D. So option is plus. Byproduct is MgODBr. So OD minus reacts with Mg plus, MgODBr. D plus reacts with minus. So here deuterated benzene is formed. So option is D. So very important. Next, if here water is present, H plus OH minus, benzene is formed. Directly H is added to the benzene ring, benzene is formed. So when toluene reacts with the Cl2 in the presence of iron, in dark the products are toluene. Toluene means methyl benzene. If benzene contains methyl group, that is called methyl benzene. Its another name is toluene. When toluene reacts with chlorine in the presence of iron. So chlorine in the presence of means FeCl3 again plus Cl2 is formed. Excess of chlorine is present. When reacts with the Fe, it forms FeCl3 plus Cl2. FeCl3 Cl2 means that is Friedel-Crafts halogenation reaction. FeCl3 Cl2. So then Friedel-Crafts halogenation means if methyl benzene is present, methyl is ortho-para directing group. Methyl is alkyl group. Alkyl groups are ortho and para directing groups. So then chlorine is substituted at ortho position and para position. So already methyl is present. One chlorine at ortho position, one chlorine at para position. So parachlorotoluene and orthochlorotoluene is formed. So major product is parachlorotoluene. So minor product is orthochlorotoluene. So answer is orthochlorotoluene and parachlorotoluene. Okay, note this.